Hello everybody, Chris here, and in this video I wanted to talk to you guys about ECS, Entity Component Systems, the options you have for Godot 4 or adjacent game engines. So there's really four types I've kind of explored to a reasonable degree. There is GECS, which is Godot native. This is GDScript. So it's a ECS entity component system that you can use right within Godot as an add-on, and then you build your code on top of it. Then another option I was exploring, if you watched my last videos, I thought that this would be a really good idea, but I've actually kind of decided against it, which is you build your game with C# Godot, and then Friflo is a ECS system that is agnostic to any game engine. So you could technically use it with Unity or Godot or any other C# based game engine. Okay, then a third option, which is pretty interesting, is using Godot as your presentation layer, your main game engine, and then Bevy as your ECS framework, where you bridge Bevy to Godot, and you can use Godot like GDScript as the presentation wiring for your ECS backend here. So that's an interesting option as well. And then of course you could go pure Bevy, which is really more of, I think, a game framework than a engine all by itself. So on this side of things, Bevy gives you the ECS framework, and then there are all of these GitHub repos where people build on top of that. So you have kind of like plugins to Bevy, like Avian 2D Physics. And then you'd have other plugins like Leafwing Input Manager, and you also need tilemap logic, which you can get from plugins, or you can build all of it yourself. So when you go the Bevy route, it's very piecemeal. You assemble everything yourself and put together your game. So the upside of Bevy is that because it's built on Rust, it's theoretically very performant. The downside is that you don't really have an editor to work with. So in that sense, it's probably harder. But then Bevy as a package that you would use with Godot, of course, because you're bridging one language to another language, you're going to have some bridge code here. You can use GDScript for presentation, and that allows you to manage your Godot nodes, which is everything from your 2D objects, your 3D objects, your UI controls, and everything else. So this is an interesting concept. Last I checked, though, the Godot Bevy project, I'll actually pull it up right now. So the last full release of this on the GitHub was 0.11, which was 5 months ago. That doesn't mean you can't use it, but it means that you might have some issues if you're trying to use the latest version of Godot. So officially, it supports 4.6, though Godot is on 4.7 already, 4.7.1 in fact, and I think they have some development versions of 4.8 at the moment. So that's interesting because you get the benefits of the Godot editor. Godot editor makes it much easier to build UI, to set up your animations for your characters, and all of that other presentation thing, where if you build with Bevy, pure Bevy, basically everything you're doing is code out of the box, and you have to assemble everything. So Godot actually does give you a lot. If you use the Godot game engine, then you have the physics engine built in, you have the input mapping, you have controls, which are pretty easy to use and assemble into the game UI that you actually need. So yeah, Godot is pretty nice in that sense. So then you have like the C# Friflo idea. Well, I had that idea anyway. So with C# you can natively use nodes and controls. So it's pretty good in that sense. Friflo is engine agnostic. And if you actually look into it, there are several C# ECS systems that are also engine agnostic out there. The reason I was trying Friflo was that it stresses having no unsafe code in its backend, and it's also really performant, so I thought it would be a pretty good option. So one of the issues here, if you want your game to be pure C# Godot, is that it becomes very DIY. It's not like Bevy, where Bevy being the framework, people have built around it. There's a lot of plugins into Bevy that can make your life easier, so you can kind of piece everything together. So if you want your game to be like pure C# Godot plus an ECS system, then you're kind of building everything yourself out of the box. Okay, and then the other thing I think really bugged me is whenever you hit the play button, you kind of have to wait about 2 or 3 seconds before you can actually launch the game. Even if all you were doing is like tweaking a setting in the inspector or loading in a new image, not changing the code altogether, but also it's every time you hit play. So if you close your game and then you want to hit play and play the game itself, like literally nothing changed, then you have to wait for that 2 or 3 seconds for it to actually play. Which if you build your main game core in GDScript, you never have to deal with that because GDScript is an interpreted language. And then C# is going to have that .NET build check. So if you try Bevy or coding with C++, obviously they have a much longer compile time, like a minute or something like that. But that's only when you actually want to make changes to your code base. So if you just want to relaunch the same game that already compiled successfully, then it's basically instant. And I find that a lot less annoying than having to wait 2 or 3 seconds every time I hit play. Now, I'm probably just really fussy about that, but yeah, that can be kind of annoying. Then finally, although there are many other options, there's GECS over here, which is Godot ECS. If you stick to GDScript, or at least if the core of your game is written in GDScript, then you have the advantage of instantly hitting play, and then you can check your game out and see if everything's working correctly from a visual standpoint without needing to compile or wait for like that 2-second delay that you would get with a C# based project. And I won't really touch on it too much, but I guess a downside might be there's no compiler, so it's probably easier to get hidden bugs or syntax errors in your code since there's no compiler to check if everything works, but that's just the nature of an interpreted language versus a compiled language like the ones on the right. So specifically with GECS, this is the slowest option in theory as far as handling the GECS logic. So in that sense, it might mean less entities. However, I think for the vast majority of games, that doesn't really matter. So it's like, are you actually going to have more than 1,000 characters in your game simultaneously that all need to be processed in the background, not necessarily shown on screen, but processed in the background, handling their logic? Then yeah, GECS might not be enough. You might not want to write your game in GDScript. So like over here in Rust, you'd have more performance and more entities. However, I don't think this is really a big deal. Most games have maybe 20, 50, 100 guys. So it's like not really a big deal. Okay, so I think one of the really smart things about Godot is that a lot of it is optimized with C++ in the background. So if you're using Godot Physics or you're using Godot Pathfinder, like 2D A star or whatever it's called, then that's actually all written in C++. The renderer for your 2D and 3D objects as well. So even though you write most of your game logic in GDScript with Godot, the engine itself is pretty well optimized. But then you might say, oh, you have some custom game logic that you need to tie into your main game loops, right? And it's like a hotspot. So there's a performance issue, and GDScript is too slow for that. So if you run into that issue, and I think this would only happen like a couple times in a typical game project maybe, then with Godot you can actually write a GD extension module. So basically you write compiled code in the language you want, which could be like C++ or Rust, and I'm sure there's other languages also. And then for that bit of logic that needs to like iterate a lot of times or on a lot of different characters, then you can just optimize it there and you can keep everything else in GDScript. So like 2% of your code can just be C++, And then 98% of your game code is GDScript. And then for things like inventory systems or calendar systems, like my calendar time plugin, it being in GDScript doesn't really matter because it doesn't actually take that much of the processing time. The thing you hit as the performance is, I think it's usually like the rendering of too many objects on the screen at once, or it is pathfinding, both of which are basically handled by the game engine itself. So you don't have to worry about that too much. So beyond that, one thing in Godot, if you do need to kind of optimize things like grass objects, there is, hold on, let me think about it. Multi-mesh instance 2D or 3D. So if you have like 10,000 grass objects and you just need them to show their visuals, then you can use this as a Godot node, which is highly optimized already, and you don't really need to worry about that too much. So the TLDR is right now in the current prototype for my game, I'm using GECS. I did try all 4 of these to some degree. The reason I like GECS is the instant feedback, the simplicity of using GDScript. There are aspects I don't like about it, like you have to be kind of vigilant in statically typing your variables to make sure everything connects between scripts well. But the performance gap you get from using GECS, I find, doesn't really matter because most of the performance is more in the visuals, so the pathfinding, and that stuff can just be completely separate from the ECS system to begin with. What ECS does give you either way is you can skip the node hierarchy when you need to query objects for running systems processing on them. Because once you turn your node stack into a entity, so you'd have your Godot nodes, but really when they're represented as a data form, it's an entity. Then they have the components, which kind of defines the differences between each entity and allows you to query them separately. And then the systems, which are going to do the processing, they don't need to mess with the Godot node hierarchy and like see which one is a child of the other. You just find the entities, which are kind of in this GECS registry. You filter by the components, and then the systems just process whatever functions need to go on all of the entities that meet those requirements and have been pre-filtered. So in my mind, it's more about the architectural benefit of pulling things out of the node hierarchy and less about the pure performance of everything. At least that's how I currently feel about it. My second fallback, if I was to choose a second, I'd probably go pure Bevy, honestly. Which would mean dropping the Godot engine. But the problem with Bevy right now is that they don't have a front-end editor. So if you want any of that presentation aspect, then it becomes a lot more of a pain and you have to piece everything together yourself. So it's probably a lot more time to actually develop the full game. And, you know, at this point for me, I just kind of care about actually getting the game done. So in my opinion, this is just kind of the way to go. In terms of prioritizing getting the game done faster than necessarily trying to eke out every little bit of performance that you could. And remember, of course, GD extension means you can optimize where you need to optimize. So if you do hit a performance issue, you can just make your code better, or you can optimize that little bit that is a hot path into a different language anyway. So I do want to emphasize, I'm just a guy that tried out some different ECS frameworks, but hopefully this gave you a little bit of insight before you dive like deep into these kind of things. And maybe you learned something from the video so you don't need to spend months figuring it out. So I've been Chris, thanks for watching to the end, and I will see you guys in my future video content.